Practice paper number 1. Question number 1. Function question given here. If R to R given fx 2x plus 1 and gx gx is x squared minus 1. Ask and show if function is bijective function. That means we have to show 1 1 and 1 2. Right. To show 1 1, we'll take, we have to show this if x function is 1 1 function. For this, what we do, we take two images fx1 and fx2. There are two ways of showing a function is 1 1. First, we can take this way, fx1 equals fx2, right? And thereafter substituting for this and simplifying, showing x1 equals x2. Secondly, taking fx1 not equal to fx2 this way and showing x1 not equal to x2. That's the ways, right? Then I'll take here fx1 equals fx2, right? fx1 means 2x1 plus 1, fx2 2x2 plus 1. Then this 1 we can take this side, 1 minus 1 we can cancel down. 2x1 is equal to 2x2, 2 and 2 we can cancel down, x1 equals x2. Therefore, f is 1 1, right? Secondly, to show this is onto function, bijective means it should be 1 1 and onto both, right? We take fx means y, fx means the image, y, 2x plus 1, right? Now, here x is in the domain R, y is in the codomain R, right? X R and y also in R, right? Now, we have to show this way. We'll subject x by this, taking this one this side and dividing by 2. This gives us x equals y minus 1 divided by 2. Okay. Now you can see here, y is any image in the codomain. Codomain is a set of real numbers. When you put any element taken from the set of real numbers for the place of y minus 1 divided by 2 will be another real number. Whatever the real number to the right hand side we get, since it is a real number, that is available in the domain. So therefore, this says for any element in the codomain, there exists pre-image in the domain. That says the function is onto function, right? So you can now write for any y belongs to R codomain, right? Y minus 1. Here 2x plus 1, no? Y minus 1 divided by 2. Y minus 1 divided by 2 belongs to R. Therefore, for any y belongs to R codomain, right? There exists pre-image x. Pre-image x in R domain. Then, therefore, the function is onto function. Therefore, the function if function is onto function. So 1 1 and 1 2 means function is bijective, no? Hence the function is bijective. Hence, f is bijective. Bijective function. Okay. Asking to show next one GOF 3 equals 48. GOF 3. GOF3. That means f and g function. So this is written as how G f3. Right. F3. How to take F3? Put x equals 3. 2 into 3 plus 1, 7. G7. Put here x7. When you put here 7, we get G7. Same 7 we have put here. 7 squared minus 1. This is 48. Therefore, GOF3 48. That's the first question. Right. Second question, trigonometry. Sin alpha 1 over root 10 and cos beta minus 1 over root 5. Here alpha is greater than pi by 2, less than pi, greater than 90, less than 180. Okay, then alpha should be obtuse angle. Beta also greater than 90, less than 180. Both are in the second quadrant. Alpha is this way, right? Beta also second quadrant. And we need to find sin alpha plus beta, right? So we know sin squared alpha plus cos squared alpha equals 1. We are supposed to find cos alpha. Cos squared alpha is 1 minus sin squared alpha. For this sin squared alpha, this can put there 1 over 10. Then here we get 3 over 9 over 10 cos squared alpha. Then we have to take square root of this. We have to put plus or minus. Right. We have to put plus or minus. 3 over root 10. But this alpha is in the second quadrant. In the second quadrant, only sign is positive, cos is negative. Therefore, out of these two signs, we have to select plus minus sign. Right? Cos alpha minus 3 over root 10. And now we will take this one, beta. The same way we can find sin beta. We can write sin squared beta plus cos squared beta equals 1. We need to find sin beta by that. 1 minus cos squared beta. Sin squared beta is equal to 1 minus cos squared beta. Mean square of this 1 over 5. We get sin squared beta 4 over 5 sin beta. Take the square root plus some minus. Right. Beta in the second quadrant. Second quadrant sign is positive. Therefore, this time we have to select plus sign. Right. Then sin beta. Sin beta is equal to 2 over root 5. 2 over root 5. Right, no? Then we need to find sin alpha plus beta, no? Sin alpha plus beta. it is sin alpha cos beta plus cos alpha sin beta. Sin alpha 1 over root 10 cos beta minus 1 over root 5 cos alpha minus 3 over root 10 sin beta 2 over root 5. Right. Then we get the answer root 10 root 5 means root 50. No? Root 10 root 5 is root 50. Root 50 means 25 into 2, 5 root 2. 5 root 2 and here minus 1 minus 6 minus 7. This is the answer. Okay, no? Root 10 root 5 is root 50. 50 we can write inside root sign 25 into 2, no? Root of 25 is 5, 5 root 2, this one. Okay, number 3. A minus 3, 2, B minus 1. The point C x bar y bar is such that AC CB 2:1. Find x bar y bar when C divides AB internally and externally, right? Okay, that case we can do here. First part, internal case. That means the point C is in between A and B. Here A, here B. A minus 3 comma 2. B minus 1. Here we have C bar, y bar, ratio 2:1. Right. Now you know ratio theorem. X bar we write 2 into 3, 6 plus 1 into minus 3 divided by 2 plus 1, 3. Y bar we write similar way 2 into minus 1 minus 2, 1 into 2, 2 plus 1, 3. Then here we get 1. Here we get 0. Then C going to be 1, 0 in the internal case. External case. In the external case, C should not be in between A and B. So, external case, second case. AC, CB 2:1. Here A, somewhere here we have B, this is C. A to C 2 units, this is 2 units. B to C 1 unit. A minus 3 comma 2, B 3 1. Let us take C as x bar y bar. At this time, you know the way. There are two ways. In this case, we can take this coordinates of C in two ways. First, we can consider it how AC in between A and C be available. Then AC is divided by B internally. Considering internal case, we can take the answer. If not, we know there's another formula for the external case that also we can use here. That is, when you consider A and C, for this AC, the corresponding ratio is that into b coordinate, right? So this 2 is the ratio connecting a and c, no? Then with this 2 we multiply not c and a, both the other one, minus this 1 connecting c and b, no? 1 should be multiplied with coordinates of a. That is the method of using the external case directly without converting this to internal case, right? So then x bar we can write, right? 2 into 3, 6. We put minus 1 into minus 3 divided by bigger ratio figure minus smaller one. This thing. For the y bar also we take the same way, right? 2 into minus 1 minus 2, 1 into 2, 2 divided by 2 minus 1. Here we get 9. Here we get minus 4. Then c this time come in 9 comma minus 4. This we can take c, right? We can take c like this, huh? Right. Next one, number 4. Fx given ax cube plus bx squared cx minus 2. ABC real numbers. It is given that x minus 1 and x plus 1 are factors of fx, right? X minus 1, x plus 1 are factors of fx, right? X minus 1 factor, x plus 1 factor. X minus 1 factor means if 1 is 0. X plus 1 factor means if minus 1 0. Right? And when fx divided by x minus 2, remainder is 12. What is that? F2 is 12. F2 is 12. So that a equals 1, b equals 2, and c equals minus 1, right? So then if 1, how to take? To get f1 here, put x equals 1. Then put on the right hand side also x equals 1. Then you get the value of f1, which is equal to 0. Once you put x equals 1 here, what do you get? 1 into a into 1 cube, b into 1 squared, c into 1 minus 2. That is the value of f1, that is equal to 0. You get a plus, b plus, c, take this to the right hand side 2. Equation number 1. If minus 1 means put here minus 1, right? Secondly, a minus 1 to the power 3, b minus 1 squared, c minus 1 minus that also 0, right? That also 0. Minus 1 to the power 3 is minus 1 minus a minus 1 squared is plus b minus c is equal to, take this right hand side 2. Number 2. F2 12, put x equals 2 here. Right. Then we get a into F2, no, to the power 3, b 2 squared, c into 2 minus 2 is equal to 8. 2 to the power 3 is 8, here 8a, 4b, 2c, take this right hand side 14. Number 3. Now to find this ABC, we have to solve these 3 equations, right? I'll first write these 3 equations together. A plus b plus c is equal to 1 minus C plus B minus C is equal to number 2, 8A plus 4B plus 2C is equal to 14, number 3. Now, when you add this 1 and 2, you can see this 2 will cancel off, this 2 will cancel off, B and B, 2B, 2 and 2, 4. 2B equals 4, B equals 2, right? Okay, next one, the right, we can take next one. V is 2, A and C we need to find. Right. Now we can put there people this A, B2 we can put here by 1. That means put here 2. When you take this 2 to right hand side, 2 minus 2 0, A plus C equals 0, A equals minus C. A equals minus C coming, no? Correct, no? I did that mentally like this, huh? B is 2, no? Put this 2 here by 1. Take this 2 to right hand side, 2 minus 2 0, A plus C 0, A is minus C, right? A is minus C. Then that A equals minus C, you substitute where people? Here, or here, now by 3. Right, for this A, I put minus C. Then here we get minus 8C, 4 into B. B is 2, no? Then here 8. And 2C equals 0. Right, so then we get equals not 0, 14, no? 14. Then we get minus 6C. 8, when you take this side, we get 14 minus 8. Minus 6 equals 6. C equals minus 1, no? C minus 1 means put minus 1 here, minus minus plus, A equals 1. Therefore, equals 1. Right. This way we can take the answers. Right, now what is asking next? Also express fx in the form of product of linear factors. Right, now I can substitute for this ABC in fx. Right. Therefore, fx, we can write A is 1, therefore x cube, B2, 2x squared, C minus 1 minus x minus 2. Right. Now I can write fx from this to take x squared out, we get x plus 2. From this to take minus 1 out, plus 2. Now take x plus 2 out, x squared minus 1, we get x squared minus 1, you can factorize as x minus 1, x plus 1. This way we can write the linear factors. Number 5. Show that log b to the base a equals this. at this proof we have done in the class. Log b to the base a is equal to log b to the base c log a to the base c. Right. The proof we can do like this. Let log b to the base c I take as x and log a to the base c I take as y. Yes, we can convert b equals c to the power x, a equals c to the power y. Right? We'll take this as number 1, this as number 2. By number 2, that means by this, we'll subject this c. Right? C to the power y only a. Then c going to be 1 upon y power of a. That c we substitute in number 1. Substitute in 1. What do you get? B equals for c, I write the bracket x. But this c is a to the power 1 upon y. Now this power and this power we can multiply. We get 1 upon y into x means x upon y. Now you can convert this to logarithmic form. How? Log b to the base a equals x upon y. All right. Now substitute x and y. X is this, y is this. Therefore, log b to the base a is equal to x log bc y log ac. This way we can prove that. Second, what is asking? Hence, reduce that log b a. Yeah, this right. Now we have proved this. No, I can use it now. Log b to the base a is log bc log ac. Right. Now I'm going to use here. We put c equals b. For the letter c, we are going to put b. Right. Then what happens? For c only we put b. Log ba. For the c I put b. But what is this? Log bb is 1. We get log ba equals 1 over log ab like this. Right? This way we get that. Okay, asking to hence reduce. No. Hence reduce means definitely you have to use this. We know in the theory class we proved this in another way, but that proof is not acceptable here. Reason? After proving this, hence reduce this. Therefore, this must definitely use to take this answer. The way of getting the answer is put in c equals b. Right. Right. Now the next part is given this way. Log 27 to the base 12 is equal to a. Right. Logarithm of 27 to the base 12 is equal to a. I can write this using the change of base formula, this one, subject to the base 10. Outright base 10 I can write of the logarithm numerator and denominator. 27 here we write, 12 here we write. A. Okay. Now this 27 I can write to the power 3. Right? Log 10, 12 is equal to right hand side A. This 3 we can take before. By using this we use the cross multiplication. 3 log 10, 3 A log 10, 12. This log 12 here I write 0.3. Okay. 3 log 10, 3 A log 10.3. We know this way a product you can write as a sum. Then we get in the left hand side 3 log 10, 3 log 10 is equal to A log 10, 4 plus log 10, 3. This way. This 4 I can write 2 squared, no? That 2 I can take before. 3 log 10, 3 A log 10. This 4 I can write as 2 squared. Bring this before. Then we get 2 here. By this A, 1 multiply this. What do you get? 2A log 2 base 10. A log 10, 3 here. 3 log 10, 3 here. Just asking to subject log 10, 2, no? Bring this side. Divide by 2A. When I take this to this side, people, that becomes minus. Log 310 we can take out. We get 3 minus A log 310. Right hand side we have this. We'll bring this here. 2A is equal to log 210 like this. Huh? I took this side and took this log 310 out. 3 minus A we get divided by 2A. Then the answer coming, no? Log 210 is equal to log 310 3 minus A divided by 2A. This way we get that. Huh? Right. Hence obtain that log 16.6 equals this answer, right? Log 16.6 equals this answer, right? Log 16.6 I can write converting this to base 10 this way. The 16 I can write 4 squared now. Six I can write 2 into 3. This I can write as a sum. Bring this 2 before. this way. Right, now, we can write this the other way around. How? 16, no? 4 square is correct. The same thing you can write 2 to the power 4 also. They both are correct. 2 to the power 4 also 16. That's easier. Bring this 4 before. And now here we have 2. Right. Okay, no? Right. Now, on the right hand side, numerator, denominator, both I divide by this, log 2 to the base 10. This term we divide by this, and this. Then what do you get? We get only 4 here, because by this we divide it. That and that divisor cancel. This also cancel in. And here we get log 3 10 divided by log 2 10. I divided this term and these 2 terms by this. This divided by the same thing, this divided by the same thing. Then this becomes 1, this becomes 1. This divided by log 210, here we have. Now, for this part, I can substitute by the previous answer. Here, by using the cross multiplication, this 2a I can take here, log 210 I can take here, 3 minus a I can take here. Thereby, I can subject log 310 divided by log 210. This part I can subject. Okay. How to do that? This part we can bring via the place of 2a. 2a we bring via here. Then 3 minus a I bring via here. Then log 310 divided by log 210 we get. Then we can write but log 310 divided by log 210. This, what do you get there? 2a, when I take that way, divided by 3 minus a. That we got by the first answer here. Right. That I substitute here. Therefore, log 16 6 upon 1 plus this ratio means this 2a divided by 3 minus a. Right. Now, what I do is this numerator and these 2 terms, all 3 terms I multiply by this 3 minus a. Okay. Then what do you get? Log 16 6. This we multiply by 3 minus a. 4 times 3 minus a. This I multiply by 3 minus a. This when I multiply by 3 minus a, 3 minus a, 3 minus a, we can cancel down. We get 2a. We get log 16 6 4 3 minus a. 2a minus a is a plus 3. This is how we take the answer. Okay, number 6, inequality part, no? Y equals 2x plus 1 mod y equals mod 4x minus 1. Ask you to sketch both in the same diagram. Y equals mod, when you define this mod 2x plus 1, this mod 2x plus 1 changes at x equals minus half, no? How do you get that? When you equate this 2x plus 1 to 0, what is the x value? Minus half. Take this right hand side and divide by 2. Right. Then on the right of minus half, 2x plus 1 mod will take 2x plus 1. Left of minus half, it is minus 2x minus 1. Then first line, x greater than or equal to minus half, right? We get y, 2x plus 1 line, x less than minus half, we get minus 2x minus 1. Right. You know, when we draw a straight line, we should have 2 points. But this time I have told you, in drawing these 2 lines, that modulus changes at minus half, no? Definitely in finding 1 point, x equals minus half, we have to substitute there, right? Okay. We'll put x equals minus half here. What do you get y? X equals minus half. When I put here minus half, 2 and 2 we can cancel down, y 0. 1 point is minus half comma 0. Here also put minus half. Y becomes 0. Minus half 0. Another point we need, we'll see how to use that point. Can take this way, the x-axis, this is y-axis. Minus half is here. X equals minus half, y 0 for both. This is that point. The negative x-axis. Here positive x-axis. Positive y-axis. Negative y-axis is the origin. Here minus half 0, 1 point. Intercept is 1. Intercept means the point where the graph cuts the y-axis here. Then this line, now I can draw how join this and produce to this end. This way. Its equation is y equals 2x plus 1. This line 2x minus 1, this is 1 point, it passes through the point this. Its intercept is minus 1. Minus 1 means here. Same height coming below this here. Minus 1. We are joining this point and this point. The whole line coming this way. But the part of the line on the left of minus half only we need. So then to draw that, we join this by a dotted line to say that to draw the line, this point and this point we use. Then that line we produce this way. Right? This is the equation y minus 2x minus 1. Right. Then this graph we drew. Next one, second one is y equals mod 4x minus 1. Mod 4x minus 1. Here this 4 is a positive value. You can take that out from the mod and you can write like this. this mod x changes at 0. Then 0 here. On the right of 0, mod x is x. Left of 0, mod x is minus x. Then x greater than or equal to 0, this equation becomes now 4x minus 1. X less than 0, this equation becomes minus 4x plus 1. Sorry, minus 4x minus 4x minus 1. Now we have to draw that two lines too. Then here, this x equals 0 we must definitely put to find one point. X equals 0 when you put here, y minus 1. Here also same way, x equals 0 brings y minus 1. 0 minus 1 is 1 point to draw the both lines, right? Now, we'll see how to draw this, right? To draw 4x minus 1, we need another point. Anyway, people, through this point, both lines pass in now. 0 minus 1 point is this, right? You can draw this one. I can put people for x. For instance, I can put x value there, but you can think rather easy way to get the line like this. The line should start from here and that should be drawn to right hand side. Here, its gradient is 4. This line we must draw on the right hand side of y axis. Here gradient is 4. Here this line gradient is 2. Gradient 4 means that line should make greater angle with the x-axis than this line it makes with the x-axis. That means greater than this angle, this line 4x minus 1 should start from here. That means if we draw a line here with greater than this angle, means the line will turn like this, and when we produce that, that line will cut somewhere here. If we draw like that, that's enough. Right. This way I do it. This way I can draw it. Right. Here also, people, the gradient is minus 2, but on the left of 0, we must draw the line with the gradient minus 4. Minus 4 means, again, greater than this angle, the line we need to draw here must make with the negative x-axis. That also, right, people, going this way. Right. That means it should go this way, because this is the angle here we have. The line therefore should go this way. Understood? Okay? Right. It's very obvious thing. This is the angle, right? This is the angle this line makes with the negative x-axis. The line this must make an angle greater than this from its start. That means from start it should turn like this. Then it should go like this. You know, right? That theories we have done in the class, right? So then I draw that like this. This way I can draw that. Right. Then you know the equation of this line, y equals 4x minus 1. This line y minus 4x minus 1. Right. Now what is asking? Asking this way. Let us find this point and this point x coordinates, right? Point A we can take point A we get by the intersection of this black line and this red one. No? That means 2x plus 1 and this we have to equate. The right hand sides of those lines we have to equate. 2x plus 1 will be equal to minus 4x minus 1. Then here we get 6x minus 2, x minus 1/3. Point B. Point B we get by the intersection of this and this, then equate the right hand side. 4x minus 1, 2x plus 1. 2x equals 1. At this point we know. This point we know. This point we got 1. No? This point x coordinate we got minus 1/3. Now what is asking? First question asking the range 2x plus 1 mod 2x plus 1 mod greater than or equal to mod 4x minus 1. You know, here 2x plus 1 mod graph is this black one. Asking what? Black one is greater than, this means black one is above the red one. Black one is above the red one occurs between here. The black one is above the red one between A and B. In x letters, x terms, when you say between minus half and 1. Therefore, this happens between minus 1/3, not minus half, 1/3. This point is minus 1/3, no? Right. X less than or equal to 1, greater than or equal to minus 1/3. Here we take the equal sign because here asking the equal sign. Then this is the answer for that. Right now. Secondly, asking hence reduce the range of x satisfying the inequality this. Hence means this using this, right? All right. So we need to take this answer, no? 2x plus 1 mod greater than or equal to mod 4x. Oh no. 2 mod x. 2 mod x minus 1. This is what asking, no? X plus 1, not x. 2x plus 1. This is what asking. Asking the range of this. Asking the range of this hints, right? Now I am going to put here for x a substitution 2u. Then here we get 2u plus 1 greater than or equal to 2 times x means 2u mod. Right. Now this 2 you can bring inside the modulus sign because the outside 2 is positive. Then 2 and 2 make 4. Here we get 2u plus 1. Then really you get a familiar form. 2u plus 1 mod greater than or equal to mod 4u minus 1. This and this when we compare people, only thing is here we have x instead of x, here we have u. Then for the variable x here we got certain answer, the same answer for this variable u we must get. Okay. So therefore, for this one I can write the answer by using this, right? Then u less than or equal to 1 greater than or equal to minus 1/3. For this I wrote the answer this way by using this answer. But its u is here. What is u? Bring this 2 here, x by 2. Then substitute for this u, x by 2. Right? Then you get that answer. That's how we deduce it. Minus 1/3 less than or equal to u means 6 over 2 less than or equal to 1 multiplied by 2 minus 2/3. This, right? This is how we take the answer. Correct. Next one, number 7. At this way, you can take that answer too, right? Number 7 next. At number 7 says ABC be a triangle. ABC be a triangle. The midpoints of the sides BCCA and AB are DE and F respectively. Show that these two answers. Right. Right. ABC a triangle, right? You see, right? Here, B here, C here. D is the midpoint of this side. These two are equal. E is the midpoint of this side. Two are equal. F is the midpoint of this side. These two are equal. Right. Asking to show ADBECF is equal to 0 vector. ADBEF BECF. AD this BE CF. Right. These lines are called as medians, no? Medians. 3 medians of a triangle meet at a point. That meeting point is called as what? Centroid, G. Right. Okay, now we can write AD vector. I can write. We need this AD BECF, no? AD vector. By using the triangle law of vector addition, AD vector I can write AB plus BD. AD vector I can write AB plus BD. AB plus BD. Right, number 1. BE vector we can write BC plus CE. Number 2, BE vector here. BE vector. BC plus CE. Right. Next one, CF vector. CA plus AF. Number 3. I will add this 1, 2, and 3. AD plus BE plus CF. Right. This right hand side we have to add. Then I add it like this. AB and BC I add first. Right, no? And next one I write this CA. Next I write BD and I add CE and AF. CE and AF, right? BD CE vector plus AF vector. Right, now all the terms on the right hand side available here. AB, BC here we have, CA here we have, BD here we have CE, AF. All the right hand side vectors we have. You know, when we add two or more vectors, this addition can be done any order. Like real numbers, when we add 2 plus 3 plus 4, we can write by changing the order anyway, like that. The same thing is true for vectors. Right. AB plus BC. AB plus BC. AB vector plus BC vector. It is AC vector. For this I can write AC. Here we have CA. CA you can write, interchange this order, what? Minus AC. Right. Now, BD. BD is this vector. This is the midpoint. Then this BD vector I can write half of BC. This BD vector I can write half of BC. CE vector I can write here. E is the midpoint, half of CA. Half of CA. AF vector I can write half of AB. Right. You can see these two null vector. If we take half out, they are taking half out, I can write AB plus BC together. This and this I take together. AB plus BC. And here we have CA. Right. AB, BC. It is AC. This is AC. Half AC. AB, BC. AB, BC, AC. This is AC now. This one you can write as, taking the order other way around, minus here. This is null vector. Half into null vector means null vector. That means this left hand side sum is equal to 0 vector. This is how we take the terms. Secondly, I'm asking BC equals 2FP. BC 2FP. This we have joined F and E. We can write BC vector here. B to C vector I can write B A plus A C by using the triangle law of vector addition. This way I can write B A plus A C. B A you can write, F is the midpoint, no? Then BA vector mean 2 times BF, 2 times AF, 2 times AF, correct, no? BA vector, we need BA vector, no? BA vector, BA vector. We can write BA vector, I can write 2 times FA, right? 2 times FA. AC vector I can write, E is the midpoint of AC, no? 2 times AE. Take this 2 out. FA plus AE. FA plus AE means FE. 2 times FE is equal to BC vector. BC vector 2FE. That's how we take that answer. Number 8. Simple A vector given 4y plus alpha j, mod A equals 5. Find the values of alpha. Number 8, part 1. Simple A vector, 4 simple I vector, alpha j. Mod A equals given 5. Mod A 5. Even mod A how to write? Square root of I coefficient squared, j coefficient squared. We'll square both sides. Mod A squared, 16 plus alpha squared. Mod A squared means mod A is 5, 5 squared 25. Alpha squared is 9. Take 60 this side. 25 minus 16 is 9. Alpha squared is 9. Therefore, alpha plus 2 minus 3. What is that? At part B, given the Partial vectors of the points A and B related to the vector origin O are 4i and 2i plus 2 root 3j respectively. Find the angle BOA. Right. OXY plane. This x-axis this vector along that I. Y-axis this unit vector along j. Point A here. It's 4i. B here. I plus 2 root 3j. That is theta, the angle. Huh? Yes, but it's asking find the angle BOA. Right. Theta we need to find. We take this way, OA vector dot OB vector. OA means 4i dot OB 2i plus 4 root 3j. You know, when you take dot product between two vectors involving I and j, we have to multiply I coefficients and we have to multiply j coefficients of the vectors. Then here we have only I, no? Then this 4 and this 2 we have to multiply 8. But OA dot OB, dot product between two vectors we define OA modulus into OB modulus cos angle between them, no? OA modulus OB modulus cos theta. OA modulus mean people O to A length. It's 4. OB modulus you can take. OB vector is this, no? I coefficient squared plus j coefficient squared root. That is how we take the modulus of a vector having I and j. Then OA modulus is 4. OB modulus square root of 2 squared plus square of this 12. 2 squared is 4, no? Root 3 squared 3 into cos theta equals right hand side 8. A 12, 4, 16. Root of 16 is 4. Here then we get this 4 and this 4, 16 cos theta equals 8. Cos theta is divided by 16 half. Theta equals 16. Correct, no? Theta equals 16. Next one asking what? Ensure that the triangle OAB is an equilateral triangle, right? OAB, no? Right here, this is 60. We just now proved O here, A here, B here. OA length 4 units. This is 4 units. This is 4 units. OB length. OB length means people OB vector modulus. OB vector modulus only here we have. Right? What is the answer? 12 plus 4, 16. Root of 16 is 4. Therefore, this is also 4. All right. This in this triangle, this side and this side equal, it says. You know, when two sides of a triangle are equal, the opposite angles of that equal sides are also equal. Therefore, the opposite side to this, opposite angle to this side is this. For this, it is this. These two angles should be equal. Here we have 60. Therefore, the sum of this and this should be 120. Since these two are equal, each should be 60. Therefore, this is 60. This is 60. Then you can see all the three angles in this triangle are equal, each 60. It says triangle is equilateral, right? Therefore, OAB triangle is equilateral. This is how we take that answer. Right. Next part, number 9. The angle between two forces P Newton and 70 Newton is 120. All right. Here P, here 70. This angle is 120. Right, no? The resultant force R is perpendicular to force P. Right. This is resultant. It is perpendicular to force P. Find the magnitude of the force P and R. Okay, you know, here, this angle, its tan value we can write. Tan 90 is equal to, we know how to write its right hand side. Or this both, this is given as R, no? 70 sine 120 denominator plus 70 cos 120 and here P. You know, tan 90 is infinity, right? This right hand side fraction infinity means denominator must be 0. It says P plus 70 cos 120 should be equal to 0. P cos 120 minus half. Here we get 0. P equals 35 newtons. And then what is asking next? R asking. Resultant force you know how to write. Resultant force we can write R squared is equal to P squared plus 20 squared plus 2P into 70 into cos 120. Then R squared, P we know 35 perfect squared, 70 perfect squared, 2 into 35 into 70 cos 120 is minus half. These two we can cancel out. Right. So then we get here, simplifying this thing, people, 35 root 3. Simplify that, huh? Newtons. 75 root 3 we get there. Right? Simplify that. By simplifying that, you can take this answer, right? Its second part. A force F is resolved along a given direction of magnitude Pn perpendicular to this direction of magnitude Q. This way. Suppose the given force is this. Along a given direction, suppose this, perpendicular to that direction is this. The angle between these two directions perpendicular to each other. But this is P, this is Q given. Right. P is to Q is 1 is to 3. P is to Q. 1 is to root 3. It says P divided by Q equals 1 over root 3. People, now, if I take the angle between F and P as theta, F is the resultant force now. F is the resultant force now of this P and Q. Correct, no? F is a single force given. We resolved that horizontally, P perpendicular to horizontal Q. Therefore, this P and Q we know resolve parts, no, or the components. The conversely, F is the resultant of P and Q. That resultant of P and Q makes an angle theta with P. Then we know how to write tan theta. Q divided by P. Okay? Q divided by P. In tan theta, we can write Q divided by P. Right, but P divided by Q is 1 over root 3, Q divided by P is root 3. Tan theta is root 3. Theta is 60, no? Right. Find the angle between F and P, that's correct. If F is 100 newtons, find P and Q, right? F 100 newtons. Right. What is P? F cos 60. Cos theta, theta is 60, no? Right. F given as 100, no? Yes. 100 cos 60 half. P is 50 newtons. All right, Q. F sin theta. All right. F is 100 sin 60. Sin 60 root 3 by 2, no? This is root 3 by 2. Root 3 by 2. 2 and 100. 50 root 3. Root 3 is the Q. Okay. The last question. Find the partial fractions of the following: x cube, x plus 1, x minus 2. Part 1. X cube divided x plus 1, x minus 2. Denominator degree 2, numerator degree 3. Numerator 3, denominator 2. 3 minus 2 is 1. Then right hand side we must write first degree polynomial function of the type ax plus b. C over x plus 1 d over x minus 2. This way. Now multiply both sides by this. By this we multiply this term, this term, this term, this term. Then what we get? Here we get x cube. Here we get ax plus b times x plus 1 x minus 2. C times x minus 2 come in. D times x plus 1 come in. We need to find a, b, c, d. Right. We can equate x cube coefficients. X cube coefficient come in this bracket only. This and this when you multiply. Ax into x into x. Right hand side we get ax cube. X cube coefficient is a. Left hand side x cube coefficient is 1. A equals 1. Right. We put x equals 2. When you put x equals 2, 2 minus 2, this bracket 0, this product will be 0. This is 0. Put 2 here, 2 plus 1, 3, 3d. Right hand side. X equals 2 when you put here 8. D equals 8 by 3. Next put x equals minus 1. X equals minus 1 when you put minus 1 plus 1, this is 0. Then the entire product is 0. This is also 0. Minus 1 brings here minus 3c. When you put minus 1 here, minus 1 to the power 3 is minus 1. C is 1/3. Put x equals 0. Left hand side, this is 0. This bracket b, this bracket 1, this bracket minus 2, this bracket c into minus 2, here d. Right. You know ADC. Then we can substitute there. Minus 2b minus 2 times c. 1/3 d. 8 by 3. Bring this 2b to this side. Plus 2b. 8 minus 2, 6. 6 by 3 is 2. B equals 1. Right. Now this ABCD figures, we have to substitute here again and write the partial fractions. Right. Then I can write x cube over x plus 1 x minus 2 a 1 b 1, then x plus 1 there, c 1/3 1/3 x plus 1, d 8 by 3, 8 divided by 3 times x minus 2. This is how we take the partial fractions. Second one, in partial fractions, x over x plus 2 x squared plus 4. X over x plus 2 x squared plus 4. Right. Here we have linear factor, here quadratic. Then we must write a over x plus 2 bx plus c over x squared plus 4. This way we write the partial fractions. multiply this by x plus 2 squared plus 4. Here we get x. A times x squared plus 4. Bx plus c times x plus 2. Put x equals minus 2. Then here minus 2 plus 2 0. Entire product will be 0. Minus 2 squared is 4. 4 4 8a equals minus 2 a minus 1 over 4. Equate x squared coefficients both sides. Here we get a. Here we get bx and x. Bx squared a plus b. Left hand side we don't have x squared term 0. Then b is equal to minus a. B equals 1 upon 4. Put x equals 0 next. Left hand side 0. Right hand side here 4a. Here c into 2. Correct now? When you put x 0, this bracket is c, this bracket is 2. Then here we can cancel down by 2. C equals minus 2a. A is minus 1 upon 4. Then minus plus half. Correct no? Minus 2 minus 1 upon 4 minus 5 is half. Then we can substitute for a, b, c and write the partial fractions. Therefore, x over x plus 2 x squared plus 4 is equal to a minus 1 upon 4 times x plus 2. Substitute for this a, what? Minus 1 over 4. B 1 over 4x and c half divided by squared plus 4. Right, people, this numerator and this denominator both I can multiply by 4. Then this is x plus 2. Here 4 coming, no? Plus 2 divided by 4 times x squared plus 4. And here minus 1 over 4 times x plus 2. This way we can write the partial fractions.